The next problem is to find whether the given list is palindrome or not. So the palindrome is like the first and last elements will be the same recursively. So 9 and 9 are same, 4 and 4 and are same. This is the mid. And if this is the odd number list, and if we come to the even number list, these two are same, these two are same, and these two are same. This is also a palindrome. For suppose this is 9655549, and these two are not same, though this is not palindrome. Even if it is 4 and 4, these two are same and these two are not same, this is not palindrome. So very simple. We need to if for suppose if it is an array, we can traverse in the reverse direction. If it is a double linked list, then also we can traverse in the reverse direction. But when it comes to the single linked list, the only traversal is from right to left, right to left or left to right, whatever, depends on the link direction. So how we do, whenever we need to see or compare the elements in a reverse direction, the another data structure that we can make use is stack. For suppose 94549, you can start from here, start pushing the elements in the stack. 94549. So this is O of n space and this is O of n plus, and once we push it, and again we need to start traversal from here and start pop the element, compare with this, pop the element, compare with this, pop the element, compare, pop, compare, pop, compare. If you see all are equal, then this is a palindrome. So this is one more operation in O of 2n. And how can we reduce the time complexity further? If you think a little more, actually we just need to push only half into the stack but not the full, because if we have a stack here, push 9, push 4 and push 5 until this part we find the mid, and now the other make it as another list starting from here and start pushing the elements. So there are two cases again. If it is odd number list, the mid will also be inside, so one pop will be performed before that. How we will know it's odd number list or even number list? When we try to find the mid element using the fast pointer and slow pointer technique. When slow pointer here and fast pointer will be here, fast pointer will be here, and is there any element of the fast pointer? No, right? If there is no element of the fast pointer, that means that is the odd list. For suppose we have some other element here and the fast pointer is here, slow pointer is here, we got the mid. If we check what is next in the fast pointer, there is one element, that means the list is of even. Then we don't have to pop an extra pop, you just retrieve the list from here and this will be the first list and start comparing them. So that is how you keep track of the mid one, and if it keep track of the even or odd list there. That is one. And when it comes to this one, so only half list we will go, and is this is a odd list, so we do the pop operation once and then start comparing with, and we ignore this, and this will be the next list 4 5 4 9, and we start pop compare, pop compare. Okay, so this reduces the space to O of n by 2 and the operation to O of n, because we are traversing to the list only once. So we have reduced the space to half and we have reduced the time complexity to half. This is one method, and there is one more method where we don't need to use the stack. That is, we'll go this similar way, we'll find the mid. Okay, using fast pointer and slow pointer. So slope pointer is here, right? Once we get the mid, I'm taking an odd number list here. The same can be done to the even list with few modifications. So we are here, the slope pointer is here. So take out the list from slope pointer dot next, reverse it, okay. Again start traversing through the first list and second list and compare both. So time complexity would be O of n, because O of n plus n by 2, and this is also one more to plus n by 2, and this will becomes O of 2n, and but there is no explicit space, but we reverse the half stack here, so a half list here, we need to reverse it. For that we need to use the implicit stack of size O of n by 2 again. So I don't see much variation from this to this, but this is also one approach, and I don't see much difference in these two. Here we are using explicit stack, here we are using implicit stack. And one more thing, to reverse it, if you don't want to use, if you want to use the iterative method and there is no stack, absolutely the space is O of 1, but it is little tedious. But yeah, there are multiple ways. I'm gonna go with this approach because O of n by 2 space and O of n time looks good to me. And if we want O of 1 space, we can go with this approach, but the reversing the linked list should be done through iteratively, but not recursively. If you use the recursive method, again you will use the O of n by 2 implicit stack. So I hope I'm clear. I'll code this out now. So I'll name the function as is palindrome. So public static bool, because we are returning either true or false, is palindrome. You'll be given a list, maybe make it as head. What if the list is null, or if it contains only one element, we just need to return the true, because a list with one element is obviously a palindrome. As discussed, we will have two pointers, slope pointer and fast pointer. Both will be assigned to head initially, and we will have a stack. I'll call it as first half stack of nodes. Now what we need to do? We need to mark the middle, that means using a slope pointer fast pointer technique. So fast pointer dot next not equal to null, and also next fast pointer dot next not equal to null. Till that point we need to traverse. When we traverse, we need to push the elements, push the nodes of the slope pointer to the stack. So first I'll push that. Move the slope pointer by one node. Move the fast pointer by two nodes. Okay, and then first half because we'll be moving to the next to the slow pointer, but here the condition will be failed, so we need to push the element here. Slow pointer here, slow pointer. Now all set. Now we need to check uh, whether this list is odd number list or even number list. So as discussed previously, we need to check the fast pointers next. If it is null, then it is even number, it is odd number list. If it is not null, then that is even number list. If it is odd number list, we need to pop the first element from the stack to make the remaining two lists, first half and second half, equal and start the comparison. So um, if the fast pointer dot next is null, first up, sorry, first half dot pop, done. Now we need to make a second half list. Second half will becomes the slow pointer dot next. Okay, now we got two lists, first half and second half. Now we should start comparing it. While second half not equal to null, what we need to compare? The data of the popped element and the data of the second half. If you find any of these data are not equal, we need to return the false. If not, we continue comparing it. If we compare it till the end and we don't find any difference, then default will return the true, that the returning true will be at the end. So we need to check the condition, not equality condition. So not equal to second half of data, then return false. If it didn't return false, then by default return true. This will tell us whether the list is palindrome or not. That's it.